What is up, my peepholes? This is your guy, Cly, and it's time for a little DIY. For today's video, what I'm going to be doing is teaching you how to design your own custom dice mold masters using the free 3D modeling software Blender, as well as any font you want. For this project, you're going to need Blender, which you can pick up at blender.org, and I should mention that in this video I'm using Blender version 2.81a, though 2.82 is now available. It's also important to note that both of these versions operate quite a bit differently from previous editions, so while all of the operations I'm going to be using in this video are available in those previous versions, the hotkeys and layout will be a little bit different. Next up, you're going to need a font, preferably one that you have commercial usage rights for, either by buying a license for it, which tend to average around $40, or you could do what I did and select one that is free for commercial use. You'll also need any image editing software that will allow you to use fonts that are installed on your computer, a way to convert image files into vector files, and optionally, something to write with and on, because I'm going to be throwing a lot of angles at you pretty quickly because I want to fit an entire dice set into this video. Now, once you have all of your software installed and your font selected, what you're going to need to do is go into your image editing software of choice, select the text tool or whatever equivalent that software has, and then type out the numbers 0 through 20, the 10s for 30 to 90, 00, a 6 with a dot, a 9 with a dot, as well as the underscore, and then save that as an image file. In my case, I'm using the font Cardigan Titling, and I am typing it at 250 point, which will affect the scaling I'm going to be doing later on in the video. Once you have your image file, you're going to need to convert this into a vector file, and while there are plenty of options out there, including the free vector editing software Inkscape, I've found Inkscape is not the best for this project. It works just fine when I'm resizing images to use for glass etching stencils, but the geometry that it generates gets a little funky when you add a third dimension. And as such, for this project, I'm going to be using the web-based solution svgcreator.com. All you need to do is upload your image file either by doing a drag and drop or by clicking select your file, and then click convert your file. After a few seconds, it will output a vector file and then just download it. And now that we have our vector file, it's time to move over to Blender. The first thing we're going to need to do is finish prepping our font to use on all of the dice we're going to be making going forward. So generate a new file, delete the default cube, and then center your camera, either by holding down your mouse's scroll wheel and moving it around, or by moving your mouse over the compass in the upper right hand corner of the work area, holding down left click and then dragging that around. Next, we're going to import our font by going to File, Import, and Scalable Vector Graphics. Now that we have our numbers in Blender, what we're going to need to do is convert them from curves to meshes, which is as simple as selecting all of the numbers, right-clicking anywhere in the work area, and then clicking Convert to Mesh. Fortunately, when you imported the numbers, they should all still be selected, but if they're not, you can either hold down left-click and drag a box around all of them, or select them all from the list on the upper right-hand portion of the screen. And now that we've converted our numbers into meshes, we need to give them a little bit of depth since they're currently still 2D objects. And to do that, we need to switch over to Edit mode, which you can do by either hitting the Tab key or using the drop-down menu in the upper left-hand corner of the work area. Once you've switched over, we need to select everything by hitting the A key, and then we need to extrude them either by hitting the E key or by clicking Faces and then Extrude. Once you're in extrude mode, just move your mouse up a little bit in order to give them an arbitrary amount of depth, and then left click. At this stage, the thickness of the numbers does not matter. Now we need to switch back to object mode either by using the tab key or the drop down menu from earlier and finish up our number prep. The first thing we're going to need to do is move the origin for each number to the dead center, because currently it's at the bottom left hand corner of the original dimensions of your image file, and it's not doing us any good there. All you need to do to move your origin is select a number, right click anywhere in the work area, click Set Origin, and then Origin to Center of Mass Volume. Do this for 0 through 9, and while you're at it, rename them as well, because currently each number has a name of curve.blank, and that doesn't always line up with what number you're dealing with. Fortunately, changing the name is very easy. All you need to do is double click on the number you have selected in the list on the upper right hand part of the screen, or alternatively, you can change it in the Object Properties menu. And in this version of Blender, it's represented by an orange square on the right-hand side of your screen. Once in that menu, you just need to click on the name of the object and change it to whatever you like. To make things simple, I just changed the name to whatever number it happens to be. If you're wondering why I just said do that for numbers 0 through 9, that's because the double-digit numbers require one additional step. what you're going to need to do is select both digits and then join them by either hitting Ctrl-J or by right-clicking somewhere in the work area and then clicking Join. Once you've joined both digits, just do the steps I mentioned previously. Now for the final piece of font prep, we're going to need to adjust the origin point for the 6 with a dot, the 9 with a dot, as well as the underscore. First, select the number 6 and then move it to the world origin. You can do this by going to the Object Properties menu and changing its location coordinates to 0 on the X, Y, and Z axes, or alternatively, you can do the same thing by pressing the N key and adjusting the location coordinates from there. Next, I'm going to assume that you've already joined the second 6 and 9 with their respective dots, as well as adjusted their origin to the center of volume, so go ahead and select the 6 with a dot and move it to the world origin as well. Go ahead and center your view on these numbers either by dragging the work area by holding down left click on the hand icon at the upper right hand portion of the work area and then moving your mouse around, or by pressing the dot key on your numerical keypad, assuming your keyboard has one. Next, select the 6 with a dot and grab it by pressing the G key. Since we're only going to be moving it on the X and Y axes, you're going to want to hit either X or Y to lock your movement to that axis and then move it around. Once you have it about where you want on that axis, go ahead and left click to stop movement. Repeat this for the other axis you haven't moved it on, and then repeat this until you have both 6s as overlaid as possible. The last thing you need to do is change the origin point of the 6 with the dot. So go ahead and right click anywhere in the work area, go to Set Origin, and then this time you're going to set it to the 3D cursor. Repeat this process using the number 9 and 9 with a dot. Last but not least is the underscore. Once again, move this to 0, 0, 0, and this time we're going to be moving it down the Y axis. For this font, I found that I like to move its default origin point down the Y axis by about 4 times its thickness. So I'm going to go ahead and change its Y coordinates to negative 0.00448. Of course, this will change depending on the font. Now just set the origin point of the underscore to the 3D cursor and you're good to go. All we've got to do now is save our progress to make sure we don't lose all of this hard work, and then launch another session of Blender in another window. You're going to want to have this file open at the same time so that you can copy and paste all of your numbers as you need them. For our first die, let's go ahead and make a D6, because not only is it a cube and therefore easy to reposition for number application, but Blender is kind enough to give you one every time you launch a new file. And let's start things off by resizing this cube. The easiest way to do that is by hitting the N key and changing the cube's dimensions on X, Y, and Z to 16 meters. That's right, I said meters, because for some reason, whenever I export a model from Blender and then import it into my 3D printer's slicing software, it's 1,000 times smaller than it's supposed to be. And that's actually pretty common. However, if you don't encounter this with your 3D printer's slicing software, feel free to convert all of these measurements from meters back to millimeters. Now that we have our cube resized, we need to hop back over to our other Blender session and select numbers 1 through 6 as well as the underscore. Go ahead and copy those with Ctrl-C and then paste them into the session where we're making our D6. Because these are going to be pasted at the world origin, go ahead and grab them using the G key and just drag them out of the center of our cube. If you want to make sure you got everything, feel free to zoom in using the dot key on your numpad. Now I went ahead and made all of these dice prior to recording this video, so I'm just going to tell you the location, scale, and dimension settings I used, but keep in mind that will change depending on your font as well as how large it was when you typed it out. I'm going to be starting with the 6, and my location settings are 0 on X, 0 on Y, and 8.6 on Z. As for my scale, I'm going to be changing it to 1250 on both X and Y, and for the dimension settings, I'm going to be changing it to 2 meters on Z. And because I'm using the 6, I'm also going to grab the underscore and use the same settings for it. And now you see why it was such a good idea to change the origin point for the underscore earlier. Now, admittedly, I don't have to use the underscore here, but I'm going to be using it on each and every die that features a 6 because I like the uniformity of it. And based on the dice sets I've seen, I'm not the only one. Once we have the numbers in place, you're going to want to select the cube, go to Modifier Properties, which is represented by the wrench on the right-hand side, select Add Modifier, and Boolean. The specific Boolean function we're going to be using is Difference, which just so happens to be the default setting. Next, you're going to select the number 6 from the drop-down menu on the right-hand side of the Boolean modifier settings. Once you've done that, click Apply. Now do the same thing for the underscore. Once this is done, you can go ahead and delete the 6 and the underscore. Next, select the cube and then rotate it by 90 degrees on the Z axis. And then apply the rotation by pressing Ctrl-A to bring up the Apply menu, and then either hitting the R key or just clicking rotation. After you've done that, we're going to rotate the cube by -90 degrees on the y-axis and then apply. Now select the number 2 and then repeat everything we did for the number 6. Once that's done, go ahead and delete the number 2 and then once again rotate the cube by 90 degrees on the z-axis, apply, and then rotate it by -90 degrees on the y-axis and apply again. Now select the number 4 and do everything you did for the previous two numbers, with one exception. Instead of rotating the cube on the z and y axes, we're actually just going to be rotating it by 180 degrees on the x-axis to flip it over. Now because the proper way to distribute the numbers on most dice is to make sure the top face and bottom face both add up to one more than the total number of sides on the die in question, we're going to grab the number 3, since 3 plus 4 is 7. Once you've got that selected, go ahead and do all of the repositioning, scaling, and booleaning that we did for the previous numbers. Once you've deleted the number 3, go ahead and rotate the cube by -90 degrees on the z-axis, and then 90 degrees on the y-axis, making sure to apply between each step. Since the 6 is on the bottom, go ahead and grab the number 1 and do everything again, with the optional exception of not deleting the number 1 and instead grabbing it with the G key and just moving it off to the side for the time being. The number 1 is going to be very important for a follow-up video I have planned. Once again, rotate the cube by -90 degrees on Z and 90 degrees on Y, applying after each step. Now grab the number 5 and repeat all of the steps you did with the previous numbers again. The last thing you're going to want to do with your D6, if you're planning on following along in that follow-up video, is rotate it by -90 degrees on Y and then 90 degrees on Z, once again applying after each of those steps, and then select the number 1 and move it back to where it intersects the die. Go ahead and save this file, and then we're going to move on to the D4. Now, making a D4 is going to be a little bit trickier than a cube due to the fact that we have to activate an add-on that is included in Blender, but not turned on by default. Typically, if you want to generate a shape for Blender, you're going to need to go to Add, and then Mesh, and select the one you want from the menu. However, the shape we need in this case is a tetrahedron, and you'll notice it's not listed there. To fix this, what you need to do is go to Edit, Preferences, select Add-ons, and then in the search bar, type in Extra. Once you've done that, you'll notice that there are two add-ons, and the one you want is Add Mesh Extra Objects. Go ahead and click the box next to that one and we're good to go. Once you've done that, go ahead and close the Preferences menu and then hit Add, Mesh, Math Function, and then Regular Object. Once you've done this, you'll have a tetrahedron, but for future reference, at the bottom left-hand corner of the work area, you'll notice a little box popped up. Go ahead and click on that and you'll see all of the different options you have for not only this object, but for most of the ones we're going to be working with in this video. First things first, we're going to need to reposition and resize this D4. So hit the N key, change the D4's dimension on Z to 20 meters, hit Enter, and to make resizing it easier on the X and Y axes, go ahead and highlight the scale on Z and then paste that number in the scale settings for X and Y. And then apply the scale using either Ctrl-A and then S, or by hitting Ctrl-A and clicking Scale. And then rotate the D4 by -30 degrees on Z, apply, and then 180 degrees on Y. Apply. Now select the session of Blender that has your numbers and copy the numbers 1 through 4 and then paste them into the session where you're making the D4. Now I'm going to be starting with the number 4, and the location I used previously was 0 on the X-axis, 6 on the Y-axis, and 5.6 on the Z-axis. For scale, I went with 800 on both the X and Y axes, and I gave it a thickness of 2 meters on the Z-axis. When I have that done, I'm going to select the D4 and once again apply a boolean modifier using the different setting and the number 4 as the target. However, I'm not going to delete the 4 after applying the modifier. Instead, I'm going to rotate the D4 by -19.47 degrees on X, apply, then rotate it by 120 degrees on Y, apply, and finally 19.47 degrees on X, apply. After I've done that, I'm going to go ahead and apply another boolean modifier with the number 4 as the target, apply, and then do that rotation and boolean combination one more time. After you've done that, feel free to delete the number 4 and then rotate the D4 by 120 degrees on the Z axis, making sure to apply the rotation. Next, select the number 3 and do with it the exact same thing you did with the number 4, with the exception of deleting it at the end if you're planning on following along for that follow-up video. Instead, what you're going to do is change the origin for the number 3 to the 3D cursor and then just move it off to the side. After that, rotate the D4 by negative 120 degrees on Z and apply the rotation. Now select the number 2 and do everything with it that you did with number 3, including the part where you set the origin to the 3D cursor and then move it off to the side if you're going to be following along with that future video. To bring up the blank corner where you're going to be putting the number 1, first rotate the D4 by negative 19.47 degrees on X, 120 degrees on Y, 19.47 degrees on X, and then negative 120 degrees on Z, making sure to apply after each rotation. Now repeat the steps with the number 1 that you did with numbers 2 and 3. Once you've done the third Boolean operation with the number 1, we're going to want to reposition the D4 in such a way that the face with numbers 1, 2, and 3 is on top. Just rotate the D4 by negative 19.47 degrees on X, 120 degrees on Y, and then 19.47 degrees on X, making sure to apply after each step. Now select either number 2 or 3, change its location to 0 on all 3 axes, and then rotate it on the Z axis by either 120 degrees or negative 120 degrees in order to line it up with the proper indentation. And now you're ready to follow along with that future video. Go ahead and save your file, and let's move on to the D8. To make the D8, first delete the default cube and then go to Add, Mesh, Regular Solid, and then using that dialog box I showed you earlier at the bottom left-hand corner of the screen, you're going to select octahedron from the drop-down menu. Once you've done that, we need to reposition and resize the D8, so go ahead and hit the N key, and then rotate it by 45 degrees on the Y-axis, apply, and then by 35.265 degrees on X, apply. Next, you're going to change the Z dimension to 16.4 meters, and then copy the Z scale and paste that for both X and Y. Once you have all of that settled, go back over to your session where you have your numbers, copy numbers 1 through 8 as well as the underscore, and then paste them into the project where you're building your D8. I'm going to be starting this off with the number 8, so go ahead and select that. And I'm going to be setting its location to 0 on both the X and Y axes, 8.6 on the Z axis. I'm going to be changing the scale on X and Y to 1000 and the dimension on Z to 2 meters. After I've done that, I'm going to select the D8 and apply a Boolean modifier with the number 8 as my target. Once that's done, I'm going to delete the number 8 and then rotate the D8 by negative 35.265 degrees on X, negative 90 degrees on Y, and then 35.265 degrees on X, making sure to apply after each rotation. Now we're going to grab the number 2 and then repeat everything we just did. On this blank face, I'm going to be using the number 6, so I'm also going to be grabbing the underscore and repeating everything I did with the previous 2 numbers. Now on this blank face, I'm going to be doing the number 4, but after I complete this Boolean operation, I'm going to be rotating on X by 180 degrees. Keeping with the logic that I mentioned during the D6 portion, I'm going to be grabbing the number 5, since 5 plus 4 is 9, and then doing the same rotation and Boolean combination I did on all of the previous numbers, not including the 180 degree flip on X. The remaining numbers I'm going to be doing in the order of 3, 7, and 1, and of course if you want to follow along with that future video, don't delete the 1. Now save your file and let's move on to the D10. Now generating a D10 is going to be a little bit more involved than all of the other dice due to the fact that it's not a regular solid. First off, we need to go to Add, Mesh, and then Cone, and once you've done that, go ahead and click on the dialog box at the bottom left-hand corner of the work area. Here you're going to change the number of vertices to 5, radius 1 to 2, leave radius 2 as 0, and then change the depth to 2.25. After you've done that, go ahead and left click anywhere in the work area in order to finalize these settings. Next, select your cone, copy it with Ctrl-C, and then paste it with Ctrl-V. Once you have your second cone, go ahead and hit N in order to bring up the properties, then rotate it on X by 180 degrees and apply the rotation. Now that we have 2 intersecting cones, we're going to need to apply a Boolean modifier to one of them. So go to Modifier Properties, click Add Modifier, and then Boolean. However, this time, instead of using the difference modifier, we're going to go with the intersect modifier. So select that from the drop-down menu. And in the other drop-down menu, select the second cone as your target. Once you click Apply, you'll notice that one of the cones has pretty much disappeared while the other is still hanging around but looking a little funky. Once you select and delete the remaining complete cone, you'll now have your D10. And for the curious, the name of this shape is pentagonal trapezohedron. All we have left to do now is to reposition and resize this D10, so go ahead and rotate it by negative 54.3 degrees on X, apply, change the Z dimension to 17 meters, copy the new Z scale, and then paste it in the X and Y scale fields. Once you've done all that, hop back over to the other Blender session where you have your numbers, copy numbers 0 through 9 as well as the underscore, and then paste them into this project. I'm going to be starting out with the number 6, and I'm going to be moving it to the location of 0 on X, negative 0.75 on Y, 9 on Z, changing the scale to 1000 on both X and Y, and finally I'm going to be changing the Z dimension to 2 meters. And because this is the 6, I'm going to do the exact same thing with the underscore. Once the 6 and underscore are in position, go ahead and select the D10 and do a couple of boolean modifiers using the different setting with both the 6 and underscore as the target. After that, go ahead and delete the 6, but keep the underscore and move it to the side because you will be using it for the 9 later on. To bring up the next face, first rotate the D10 by negative 35.7 degrees on X, apply, and then negative 72 degrees on Y, apply, and finally 35.7 degrees on X, apply. Repeat this rotation and boolean combination for numbers 4, 8, 2, and 0. However, after you delete the number 0, we're going to be rotating the D10 by 180 degrees on X as opposed to the negative 35.7. And it's at this point I'm going to be deviating from the more common D10 layout because there's a little bit of a flaw in their design. As I've mentioned multiple times in this video, dice are typically laid out in such a way that the side on the top and the side on the bottom add up to be 1 greater than the number of sides on the die. However, the person that designed the D10 layout that most companies use today decided to treat the 0 as if it was indeed a 0 and not a 10 that's just been truncated to fit with the single digit aesthetic, and then have the opposing sides equal 9. So if I was going to follow their design, I would be telling you to grab the 9 and then repeat the boolean and rotation combination that we've been doing so far. However, that means that the opposing sides are all going to equal 9, with the exception of the 0 and 9, which will equal 19. And I don't want that. Even worse is the D10 that is included in the mold set that you can pick up from Wish or AliExpress, because that one seems like the person that designed it just threw crap at a wall to see what sticks. Admittedly, you do have the 5 across from the 4, which does equal 9, but if you move over to the 0, you have the 1 across from it, which would bring you to 11, or 1 depending on how you're treating it. The 8 is across from the 9, which brings you to 17, and it just gets worse from there. But I think I've ranted enough, so let's get things back on track by selecting the 1, and then doing the same boolean and rotation combination we were doing previously. Though, if you're going to be following along with that future video that I keep talking about, go ahead and move the 1 off to the side instead of deleting it. Following the 1, you're going to have the 9 plus the underscore, 3, 7, and 5. And for those of you planning to follow along with that future video, after you've deleted the 5, do one more rotation combination to bring the 1 back up to the top, and then place it at the original coordinates. As for the percentile die, you're pretty much going to do exactly what we just did with the D10, with the main exception being the fact that you're going to be using the 10s from 10 to 90 as well as 00 as opposed to the single digits. And because they're double digits, they are going to have some different settings, so the location is going to be at 0 on X, negative 2.5 on Y, and 9 on a Z. The scale is going to be 750 on both X and Y, and the dimension on Z is going to be 2 meters. After that, I followed the same numbering pattern as well as the boolean and rotation combination. And of course, keep the 10 if you're going to be following along with that future video. Now go ahead and save your files, and let's move on to the D12. Now it's time for the D12, so go ahead and delete your default cube, go to Add, Mesh, Mathematical Function, Regular Solid, click the dialog box at the bottom left-hand corner of your work area, and from the drop-down menu, you're going to select dodecahedron. To reposition and resize this, you're going to rotate it by negative 58.285 degrees on X, apply, and then change the dimensions on Z to 18.5 meters, followed by copying the scale on Z and pasting it over the scale on X and Y. Now hop back over to the Blender session that has all of your numbers, then copy the numbers 1 through 12 as well as the underscore, and then paste them into this project. For this die, I'm going to be starting with the 12, and after hitting the N key, the settings that I used for these numbers are a location of 0 on both X and Y, as well as 9.75 on Z, a scale of 1000 on both X and Y, and a dimension of 2 meters on Z. Once I have the 12 in place, I'm once again going to select the D12 and do a boolean operation with the 12 as the target. Delete the number 12 and then rotate the D12 by 36 degrees on Z. And at this point, I'm going to tell you it's going to be a bit different from the dice we did previously because everything is going to rotate around the 12 as a central hub, at least when it comes to the even numbers. With that in mind, go ahead and rotate the D12 by 63.43 on X, but do not set the rotation. Now select the number 8 and use the same settings you used for the number 12. Once you boolean the D12 using the 8, delete the 8 and then change the rotation of the D12 back to 0 on X to bring the 12 back to the top. Now rotate the die by 72 degrees on Z and apply that rotation. Now you're once again going to rotate the die by 63.43 on X, do everything you did for the number 8, for the number 6, and then repeat everything for the numbers 4, 2, and 10. And of course, when you use the number 6, also grab the underscore, but don't delete it because you'll be needing it for the number 9 later. Once you've deleted the number 10 and brought the 12 back to the top, rotate the die one more time by 36 degrees on Z so that the number 12 is aligned vertically on the Y-axis, and then apply that rotation. Now rotate the die by 180 degrees on X and apply that rotation. Grab the number 1 and repeat everything you did for the number 12 because this will be acting as our central hub for all of the odd numbers. And once again, if you're planning on following along with that future video, do not delete the number 1 and instead move it off to the side after the Boolean operation. You're going to be following the same rotation and Boolean combination that you used with the even numbers, and this time you're going to be doing it in the order of 3, 11, 9, 7, and 5. Of course, make sure you also include the underscore with the 9, and this time you can delete the underscore when you're done with it. This last optional step is for those of you eagerly anticipating that future video that I keep teasing. So after you've deleted the 5 and brought the 1 back to the top, rotate the die one more time by 36 degrees on Z to align the 1 vertically on the Y-axis, and then apply that rotation. And finally, bring the number 1 back to its original coordinates. Now go ahead and save your file and let's round things out with the D20. Now that we've finally reached the D20 stage, you should probably brace yourself because there will be a lot of angles thrown at you thanks to the number of sides. With that warning out of the way, go ahead and delete the default cube that Blender loves to give you, and then go to Add, Mesh, Mathematical Functions, Regular Solids, click the dialog box in the bottom left-hand corner of the work area, and select icosahedron from the drop-down menu. As for repositioning and resizing the D20, you're going to rotate it on X by 20.905 degrees, apply the rotation, and then change the Z dimension to 20.7 meters, copy the Z scale, and paste that on the X and Y scale. Now hop back over to your other Blender session one last time to grab the numbers 1 through 20, as well as either the underscore or the 6 and 9 with dots. Depending on how large your font is, I've found that the underscore works just fine with this font, so that's what I'm going to go with. I'm starting with the number 20, and after hitting the N key, the location settings I'm using are 0 on both X and Y, as well as 11 on Z, a scale of 520 on both X and Y, and a dimension of 2 meters on Z. Select the D20 and perform a Boolean difference operation with the 20 as the target, delete the 20, and get ready for a lot of numbers. Just like with the D12, we're going to be treating the 20 as a central hub, but due to the number of sides, there will be some offshoots from each side that touches the 20. So now you're going to rotate the D20 by 60 degrees on Z, apply the rotation, rotate by 41.81 degrees on X, apply the rotation, grab the number 14 and use all of the settings that I told you for the 20, do the Boolean operation and then delete the 14, rotate the D20 by 60 degrees on Z, apply the rotation, then rotate it by 41.81 degrees on X, but do not apply the rotation, grab the number 6 with a dot or the number 6 and the underscore, and use the same location, scale, and dimension settings that you've been using. Once you've Booleaned the D20, deleted the 6, and set the optional underscore off to the side, go ahead and change the D20's X rotation back to 0, and then rotate it by negative 120 degrees on Z, making sure to apply that rotation. Rotate it by 41.8 degrees on X and do not apply that rotation. Grab the 4, use all of the location, scale, and dimension settings we've been using this entire time, do a Boolean on the D20 with the 4 as the target, and delete the 4. Now we want to bring the 20 back to the top of the die. And to do that, change the D20's X rotation back to 0, rotate it by 60 degrees on Z, apply that rotation, and then rotate it by negative 41.81 degrees on X, apply that rotation. Now that the 20 is back on top, you're going to rotate it by 120 degrees on Z and apply that rotation. And now we get to repeat the process we did with the 14, 6, and 4, using the 8, 10, and 16. Bring the 20 back to the top using the previous method, rotate the die one more time by 120 degrees, apply that rotation, and finally repeat the previous drawn out process using the numbers 2, 18, and 12. Bring the 20 back to the top one more time, rotate the die by 60 degrees on Z, apply the rotation, and then rotate the die by 180 degrees on X, apply the rotation. After doing that, grab the one that's going to act as our central hub for all of the odd numbers, use the same location, scale, and dimension settings you've been using for all of the other numbers, and optionally move it off to the side after doing the boolean operation. Now, using the same rotation and boolean combinations we used with the even numbers, you're going to apply the numbers 19, 9 with either the dot or the underscore, 3, 13, 5, 11, 7, 17, and 15. Now the last optional step is to bring the number 1 back to the top, rotate the die one more time by 60 degrees on Z, and then move the number 1 back to its original coordinates. Now save this project and you've just completed your own custom dice set masters. At this stage, you have several options. The first option is for those of you who have decided not to follow along with the future video. All you need to do is export the model as an STL file, go to File, Export, and then select STL. After you've done that, you're ready to import this directly into your 3D printer's slicing software. Of course, after you've imported it, make sure you elevate it by a couple of millimeters, rotate it by 45 degrees on X and or Y, and then finally apply some supports. If you're wondering why I said rotate it on X and or Y, that's because if you have a flat bottom on your print, you run the risk of having a little bit of clumpy buildup on the bottom if you use a resin 3D printer, which I should add is one of the best options for making custom dice masters due to the amount of precision you have. In fact, that's what I use. I have an Anycubic Photon and it's been doing an amazing job. Even better, it's not that much more expensive than an entry-level filament 3D printer. And those of you without 3D printers don't need to worry, there are plenty of online services that can print these out for you. Now the second option is for those of you that want to follow along with that mysterious future video. What I'm going to be doing is setting up these models in such a way that they produce a 2-part mold similar to the ones that you can pick up on AliExpress and Wish, except with a few improvements. The main benefit of setting up the models in this way is the fact that you don't have to add supports to the outside of the die. This means that you not only don't need to remove the supports from your dice, which I should add sometimes splinter off and leave divots behind, but you also don't need to sand off the support remnants either from the master die or from the dice cast from a mold made from an unsanded master. Also, I have things set up so that you can remove the silicone from the master die without having to cut it. It just peels right off. So now not only is making molds faster, but you don't have to worry about potentially ruining your master dice every time you make a mold. As of right now, I've already completed the master for the D10 mold, and here are a couple of pictures. If you're wondering why the mold is so lumpy, that's because I made it using a brush-on silicone as opposed to a pour-over silicone. In this case, that roll was filled by silicone caulk, and it worked wonderfully. Maybe I'll make a video in the future about making your own dice molds with caulk. Anyway, this video has dragged on for far too long, so I'm gonna go ahead and say, until next time, this is your guy, Cly, signing off.